A very good evening to all my dear lovely students. I welcome you back to your own YouTube channel Shri Chaitanya Educational Institutes. Today in the Sankalp RE-NEET class, we'll be discussing this year's question of coordination compounds from JEE Mains. I have picked up all the questions which are up to the NEET level and not going above it. Okay, so most of the questions which come from the inorganic chemistry are actually from the NCERT based only. They are all examples of coordination compounds which are there in the NCERT, and a few here and there they can ask. Okay, so my name is Anirudh Mehta, as I have taken a few classes for you before as well. I hope you are enjoying this series and you are gaining a lot of confidence after watching these videos. So today, without any further ado, let us start with our coordination compounds. So the first question, as you can see here, it's a statement type question. Crystal field stabilization energy CFSE of chromium water 6 plus 2. Chromium water 6 plus 2, chromium plus 2, meaning it's a D4 configuration with a weak field ligand. So coordination number 6. So question is coming from crystal field theory. Is greater than that of manganese water 6 plus 2. Manganese plus 2 means a D5 configuration with a weak field ligand. Okay, so question is, who has more crystal field stabilization energy? Whenever a CFSE question comes, bache, always think of the magnitude, never the sign. Okay, a more negative CFSE means more stabilization. So we need to check which has more magnitude and not the value of sign and not the sign. Okay, so when I look at chromium plus 2, it's a D4. And we know water is a weak field ligand. So when we fill D4 with the weak field ligand, we'll fill 1, 2, 3, first 3 in the T2G, and fourth one will jump here. No forceful pairing will happen. This will give you CFSE value of 3 electrons are sitting down at a level of minus 0.4 delta naught, and 1 electron is sitting up with the value of 0.6 delta naught. So this gives you minus 12 plus 6 minus 0.6 delta naught. It has minus 0.6 delta naught CFSE. Okay, magnitude only we talk about. Minus just represents this is the amount of energy released. Okay, for manganese plus 2, which is D5, we will fill it like T2G1, T2G2, T2G3, EG1, EG2. Okay, like this. So as you can see, the CFSE here will come out to be 0. 3 of the electrons are sitting at a level of minus 0.4 delta and 2 electrons are sitting at a level of plus 0.6 delta. 1.2, 1.2 cancel out, becomes 0. So yes, this one has more CFSE. So first statement is absolutely correct. CFSE of chromium 2 is more than manganese 2. Statement 2. Potassium ferricyanide. Ferri means iron plus 3. Potassium ferricyanide formula would be K3FeCN6. K3FeCN6, right? Has greater spin only magnetic moment, means mu value is more as compared to sodium ferrocyanide. Ferro means Fe plus 2. Ferro means ferrous. So formula will be Na4FeCN6. Right? Again, it's a crystal field theory question only. Iron plus 2 means a D6 configuration with a strong field ligand. D6 with a strong field ligand will be undergoing forceful pairing in the T2G, giving you 1, 2, 3, 4, 5, 6. It's diamagnetic. It is what? Diamagnetic. So mu value comes out to be 0. And here we'll have iron plus 3. Iron plus 3 is a D5 configuration. Obviously, it will be paramagnetic. I don't even have to check. A odd electron species has to be paramagnetic. So this is also a correct statement. Okay, both the statements are correct. So this gives you your option 1. It's a good question. So we have revised the concept of how to find CFSE, how to write the electronic configuration in the presence of a weak field ligand or a strong field ligand. Okay, like this. Revision of each concept will keep happening in every other question that you see, right? I hope it is clear to everyone. Moving to the next one. Next question is, identify the metal ions among these having a spin only magnetic moment value more than 3 Bohr magneton. Okay, more than 3 Bohr magneton. When we know the number of unpaired electrons are 1, 2, 3, 4, 5, the magnetic moment comes out to be 1.73, 2.84, 3.84, 4.9 and 5.8, something like that. They are asking more than 3. That means they are asking 3 or more than 3 unpaired electrons. We have to see. Okay, right. The sum of unpaired electrons present in high spin octahedral complexes. High spin means weak field ligand, no forceful pairing. Low spin meaning spin will become low when we do forceful pairing. But if we want high spin, we have to keep the electrons unpaired for the longest time possible, means weak field ligand. So let's find out. So question is, first we have to check who has magnetic moment more than 3. Cobalt plus 2 is a D7 configuration. Okay, D7 when you draw, you will get 3 unpaired electrons. So its mu value will be 3.84. So yes, I have to choose it. Nickel plus 2 is a D8 configuration. D8 means 2 unpaired electron, 2.84 Bohr magneton. So we don't have to choose this. Iron 2 is a D6 configuration, as we know. 4 unpaired electron, 4.9. Yes, I have to choose this. Vanadium 3. Vanadium is a D2S3 configuration, a D3S2 configuration. So after removing 3, we will get a D2. Okay, 3D2. So it will be 2 unpaired electron, 2.84. So we don't have to take it. And then titanium 2. Titanium is a 3D2 4S2 configuration. So it will also be a D2, 2.84 Bohr magneton. So I have chosen the two of them, which is cobalt 2 and iron 2. This one we have chosen and this one we have chosen. Now we will draw their octahedral complexes with high spin. Octahedral complexes with high spin means no forceful pairing will happen. Correct. So keeping a D6, 1, 2, 3, 4, 5, 6, 4 unpaired electron. And keeping a D7, 1, 2, 3, 4, 5, 6, 7. So here we have 1, 2, 3, 4, 4 unpaired electron. Here you have 1, 2, 3 unpaired electron. So total unpaired electron become 7 unpaired electron. 3 are here, 4 are here. So the question was the sum of total unpaired electron present in these complexes. So I can see 1, 2, 3, 4, 5, 6, 7 unpaired electrons. So answer will be 7. Answer will be 7. So it's a nice question. I hope it is clear to everyone. Moving to the next one. Another question from again crystal field theory. They are saying COBr4 2 negative ion will absorb light of lower energy than COCl4 minus 2 ion. We know that energy absorbed is directly proportional to the crystal field splitting gap. Octa means octa, because this is tetra, so I will keep it as delta T. Okay, more the splitting, more the energy absorbed, and the splitting depends on strength of ligand. It depends on other factor as well, like positive charge on the metal, size of metal. Okay, the top to bottom we have to look for the Z effective as well. But for this question, because metal is same and the charge is same, I am looking at the strength of ligand. We know that strength of ligand coming from the spectrochemical series. When I compare, the strength of ligand starts from I minus, then Br minus, then Cl minus comes somewhere. Okay, then F minus is there. So for the halides, you already know the strength of ligand. So bromide will have more strength than chloride, or chloride will have more strength. Chloride has more strength. So for chloride, delta will also follow the same order. Delta will be more for chloride. So they are saying bromide COBr4 2 minus will absorb a light of lower energy. That is absolutely correct, because chloride is a stronger ligand. It will create more gap. More gap means more energy. That's correct. Then COI4 2 minus ion, the energy separation means delta T between the two sets of d orbital is more than COCl4. This will be a wrong statement. Okay, I minus will have the least gap. So gap will be least in the I minus, more for the Cl minus ligand. So they are saying here the gap is more, energy separation is more than COCl4 in COI4. That's a wrong statement, obviously. Okay, I hope it is clear. Moving to the next one. Next is a very important, nice question, and it has been asked in NEET as well before. Let's look at it. Nickel 2 complex with dimethyl glyoxime. Most important complex, this is for your practical chemistry part as well, where nickel plus 2 is complexed with 4 nitrogens as a square planar geometry. Nitrogen, 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 nitrogen. Dimethyl glyoxime. Glyoxime means C double bond NOH. C double bond NOH. C double bond NOH. C double bond NOH. This become glyoxime. This become dimethyl glyoxime. Dimethyl glyoxime. Dimethyl glyoxime. Dimethyl glyoxime. Glyoxime has a OH group here and a OH group here. Okay. Dimethyl glyoxime will have a OH group here and a OH group here. But this reaction is done in the basic medium where one of the OH gets deprotonated and become glyoxymate. Other will remain as it is. So one of the OH will remain OH. One of the OH gets deprotonated and become O minus. So I am showing a deprotonated one on the top, here at the bottom, like this. Right? This is our NEET twice, where due to the O negative and H positive nearby, we have a hydrogen bonding here. Symmetrical hydrogen bonding is present like this. This is how the structure looks like. This is how the structure looks like for NEET twice. Remember it, it is a red color precipitate in basic medium. Because medium is basic, that's why the deprotonation has happened. The KOH would have removed the H plus from here and H plus from here, making it a the dimethyl glyoxymato. So glyoxymato is the dimethyl glyoxymato is the ligand here. So let's look at the condition now. It is red in color, absolutely correct. They are asking identify the incorrect statement. So this is to correct. A should not be there in the answer. Fourth option goes out. It has high solubility at a pH of 9, means in the alkaline medium. I just told you it's a red color precipitate in the alkaline medium. So B is absolutely incorrect. So only option third is left now. So answer will be third option. We'll still look at the other options. Nickel ion has 2 unpaired electrons in D. Nickel has 2 unpaired electrons. It's nickel plus 2, which is D8. But it's a case of strong field ligand. That's why it has gone for a square planar geometry. And you know that for D8 square planar, there is no unpaired electron. So there is no 2 unpaired electrons. This is a wrong statement. B was wrong. C is also wrong. Nitrogen nickel nitrogen bond angle is almost close to 90 degree. Absolutely correct, because it's a square planar geometry as I just told you. So bond angle will be close to 90 degree. The complex ions, the complex contains 4 5-membered metal cyclic rings. You can count the number of rings. There are 4 rings, but not all of them are 5-membered. This is a 6-membered ring. This is also a 6-membered ring. This is a 5-membered ring. This one is also a 5-membered ring. So there are 2 5-membered rings, but not 4. So B, C and E are incorrect. Okay. It's a nice question, a good complex that you need to remember about. Going to the next one. The next question is again regarding CFT. Crystal field splitting energy of CO oxalato thrice minus 3, cobalt plus 3 means D6 configuration. And as an exception, we know oxalato is strong field ligand for cobalt plus 3 only. So CFSE we have to find. What will be the CFSE? Let us see. D6 on splitting will do forceful pairing and will get 1, 2, 3, 4, 5, 6. Right? So CFSE comes out to be 6 electrons at a minus 0.4 delta naught plus 2 new pairs Only the new pairs we have to take, as all of you know. So 1, 2, 3, 4, 5, 6. Already one old pair was there. We don't have to count it. Only two new pairing energies are there. So it is minus 2.4 delta naught plus 2p. This is the CFSE. Right? Now they are saying complex. This complex ka CFSE is n times that of this complex, chromium plus 3 with oxalato. So when I take chromium plus 3, which is a D3 configuration, although it's a weak ligand, but it doesn't matter because 3 electrons, so only one way to fill, 1, 2, 3. So its CFSE comes out to be 3 times minus 0.4 delta naught, which is minus 1.2 delta naught. So they are asking this CFSE is how many times this CFSE? This CFSE versus this one. Extra pairing energy is there, but here they are saying assume that delta naught is much bigger than pairing. So neglect the pairing. I can neglect it. Okay. So this is minus 2.4, that is minus 1.2, which is double time. So n value is 2. It's 2 times. Okay. You can pause the video, solve the questions yourself first from the next one. And if you are not able to get, then continue the video with me. Okay. So I hope it is clear to everyone. Nice question. A good type of question, new type of question. Next one. Next one is coming from the spin only magnetic moment value of the complex. This one, B is copper plus 2, nickel plus 2, nickel plus 2. So I am just writing ABCD here. A, B, C, D. A is manganese plus 2, means D5 configuration with a weak field ligand. Okay, coordination number is 4. Next is B, which is copper plus 2, D9 with a weak field ligand. Although water as an exception is a strong field ligand for copper, so we'll keep it as strong field ligand. Nickel plus 2 means D8, D8 with a strong field ligand. And we have nickel plus 2, D8 with a weak field ligand. Correct. Now, if the complex is having coordination number 4, I am writing the coordination number here as well. It's a 4 coordination complex. Next is a 6 coordination complex. Next is 4. Next is 6. When it comes to coordination number 4, D5 means all the 5 d orbitals are singly filled. Weak field ligand will not cause any forceful pairing. So all 5 will remain unpaired. Magnetic moment will come 5.84 Bohr magneton. And hybridization will go for sp3 tetrahedral. Correct. D9. Anyways, almost all the orbitals are filled. We have to go for outer orbital complex. Although it's a strong field ligand, but doesn't matter. We have to go for sp3d2. And one unpaired electron will make it 1.73 Bohr magneton. D8 strong field ligands and coordination number 4 means only one room vacant is required for a DsP2 configuration, and obviously one room can be made vacant in D8 because 8 electrons can sit in the 4 d orbitals. One room can be made vacant, so it will become completely diamagnetic with a DsP2 hybridization. Okay, most important case of NiCN4 2-. I hope all of you know it is diamagnetic. And next is D8 but 6 coordination number. So in the 6 coordination, D2sp3 is not possible because you cannot make 2 rooms vacant in the n-1d with the D8 configuration. Up to D6 you could do that, but now you cannot do that. So it will go for an outer orbital complex sp3d2, and the 2 unpaired electron will remain as it is, 2.84 Bohr magneton. So it comes C, B, D, A. C, B, D, A, which is option 2. Okay. So it's a question from VBT, because when it comes to question of CFT means whenever the octahedral complexes are there, you should do the question by CFT. But when it comes to coordination number 4, you first need to find out the hybridization. You cannot use the CFT directly. Okay. So it's a hybridization related question. Okay. Next one is a question from Werner's theory. Werner's theory question. Werner is the theory which tells you about the primary valency of the metal, which is the oxidation state, and secondary valency, which is the coordination number. Question is, number of isoelectronic species among them are n. Let's see isoelectronic. Scandium plus 3 is D0. Chromium plus 2 is D4. Manganese plus 3 is D4. So yes, these are. Cobalt plus 3 is D6. Iron plus 3 is D5. So only these two are isoelectronic. So answer is 2. N is 2. N is 2. If n moles of AgCl are formed during the reaction of this complex with excess AgNO3, then number of electrons present in T2g orbital of this complex are how many? Okay, nice question again. Read the question once again. 2 moles of AgCl are formed. That means this complex has 2 ionizable chlorides. That is the meaning. When I put into excess of AgNO3, then these 2 chlorides will precipitate out as 2 moles of AgCl. That's the question. Now, we know cobalt plus 3, whenever it is present, its coordination number has to be 6. So, out of the 3 chlorides, 2 chlorides are outside, 1 chloride must be inside. Rest En2 will give coordination number 4 because these are bidentate ligands. So, 4 coordination, 5 coordination and 1 ammonia will give. So, ammonia also inside. This is the formula of complex from Werner's theory. CO ammonia 1 En2 Cl Cl2, okay, which is amine bis ethylene diamine chlorido cobalt 3 chloride. Correct? This is the complex. Now in this complex I can see that almost all ligands are strong only. It's a D6 configuration. It is a D6 configuration. It's a strong ligand. These are also very strong ligands. So D6 with a strong field ligand. We'll go for a T2G6 EG0. 1, 2, 3, 4, 5, 6, 0. So your answer is 0. T2G, sorry, T2G they're asking, so 6. In EG0, in T2G, there are 6 electrons which are present. So again, a very good question. Little bit of, challenging questions these are, where you have to read it carefully. So two concepts they have mixed together, CFT, isoelectronic nature, and Werner. Three concepts are there in this particular question. Right. Moving on to the next one. Wavelength of light absorbed. We know that if gap is more, then energy absorbed will be more. Energy is inversely proportional to lambda. And energy is directly proportional to strength of ligand. So more the strength, lesser the lambda. More the strength, lesser the lambda absorbed. Let's check for the strength. This one has the highest strength, means lambda will be minimum. Lambda will be minimum. Water, ammonia, water, F minus has the least strength. So lambda will be maximum. First the maxima minima I have checked. Okay. So this is the minimum lambda. Third one has the minimum lambda. Third, all options. Fifth one has the maximum lambda. Fifth. So first option goes out. Right. Now let's check. We know ammonia versus water. Ammonia is a stronger ligand as compared to water. So ammonia has a strong ligand. So its lambda will be less. So first ka lambda will be lesser than third ka lambda because here one water is also present. So lambda will be little more. So lambda of 1 will be less than lambda of 4. 1, 4 which is right. 1, 4 which is right. 1, 4 which is also right. Okay. And now coming from 1 water to 5 water, this will have very, very high. Higher than 1 and 4. So 2 will be higher than 1 and 4. This goes out of picture. This goes out of picture. 2 has to be more than 1 and 4. 2 is more than 1 and 4. So option 2 is correct. Okay, option 2 is correct. Option 2 comes out to be the best answer. Okay, again I am telling, I am just showing you with the signs now, with some smileys now. Cyanide is the strongest ligand, so it will have the least lambda. So this will be the last one, rank 4 or rank 5. This is the weakest ligand, so it will have the best lambda, COF6, the negative. Okay. 4 ammonias are also strong, so this is also 6 ammonias are also strong, so this is also bad only. So the worst will be third, then will be first, third, first. Then coming to 5 ammonia, which is also going to be little bit bad. And then 6 water will be the good one as compared to 5 ammonia. So 5 ammonia, then 6 water, and then 6 fluorides. So this is the order, second option. Moving on to the next one. Again a Werner theory question. It's a numerical based question. A complex of chromium is this one. Has spin only magnetic moment of 3.87. They don't have to tell us because every ligand is weak here. Either chloride act like a ligand or a water act like a ligand. For chromium plus 3 they are weak only. And 3 unpaired electrons anyways will be 3.84. So this is of no use for us. It corresponds to conductivity of 1:2 type of electron. This is important. It tells you that there is one bracket and 2 chlorides outside. This is what it is telling you. It is corresponding to 1:2 types of electrolyte. That means it's a bracket Cl2. Bracket Cl2. So inside the bracket I have to keep a chromium. And chromium needs to have 6 coordination number. For that it will take 5 water inside and 1 chlorine inside. That means the rest 6th water is sitting outside as the water of crystallization. This is a compound, 1 water, sorry. The 6th water is sitting outside as the water of crystallization. This is the compound given in the NCERT as a grey-green color compound. Okay, in the hydrate isomerism if we check. Now, question is 2.75 gram of this complex, 2.75 gram of this complex was initially passed through cation exchanger. Cation exchanger means nothing but this cation got exchanged with some other cation. Let me call it P cation, P plus 2. So we'll get it as PCl2. P is just the cation. The solution obtained after the process was reacted with excess of AgNO3, which will precipitate out all the chlorides. So 2 moles of AgCl will precipitate out. So 1 mole of this gives 2 mole of AgCl. They are saying what is the mass of AgCl formed in this process. Mass of AgCl. So I have to look at moles. Moles of AgCl are double of the moles of salt. So we can say moles of AgCl produced will be 2 times the moles of complex taken. Correct? I hope it makes sense because 2 chlorides are outside, 2 chlorides are ionized. So moles of AgCl precipitated will be 2 times moles of complex. Moles can be written as mass by molar mass. Okay, let's find out the molar mass. 52. 3 chlorines will be 106 and 6 water will be 108. Okay, when you add all of them together, 108, 106, 114, 114 plus 52, around 166 or something, 167 gram around it is coming. Okay, if I approximate it, 267, sorry, 267 around it is coming. If I approximate it, it's almost like 100 times, almost like 100 times. Okay, so I get the moles of AgCl as 1 by 50 moles, but they are asking mass. So weight of AgCl will be moles into molar mass, which is 143.5 gram. 143.5, and this comes out to be 2.87 gram. Okay, nearest integer they are asking, so I can mention 3 gram here, but real answer will be around 2.7, 2.8 gram or so. Okay, I hope it is clear to everyone. It's a nice question. It's a little lengthy question, requires a little bit of calculations. Next one. Next question says, nickel with coordination number 4 is a paramagnetic complex. Nickel plus 2. We know that nickel plus 2 is D8. If strong field ligands are there, it will become square planar and it will be diamagnetic. But if weak field ligands are there, it will go for sp3 tetrahedral, and it will remain paramagnetic. They are saying it is paramagnetic means these ligands overall are acting like a weak field ligand scenario. So it will be a paramagnetic means it has to be tetrahedral, it has to be sp3, and it is a D8 configuration, which would be looking like this. 2 unpaired electrons, so 2.84 Bohr magneton. These are the 4 things only which we can tell by looking at a complex. I have written about it. Para, tetrahedral, sp3 and D8. Okay. Complex exhibits geometrical isomerism. Not at all. So this is the mistake you will do. Looking at it Ma2B2, you will say yes, it will show cis and trans. No. Tetrahedral complexes never show cis and trans. So it was very important to find out the geometry first. They are asking identify the incorrect statement. A is incorrect. This option and this option, 2 options we are reaching to. B. Complex is white in color. As I can see D8 here, D8 has DD transition. So there has to be some color to it because of DD transition. The calculated spin only magnetic moment of the complex is 2.84. This is absolutely correct. So A and B are wrong up till now. Yes, C is correct. The CFSE value of nickel in this complex is minus 0.8 delta T. For this we have to write the CFT. Tetrahedral CFT mein we know EG set goes down and T2 sets go up. D8. Let's fill D8 with the weak field ligand 1, 2, 3, 4, 5, 6, 7, 8. 4 are sitting down at a level of minus 0.6 delta. 4 are sitting up with a level of 0.4 delta. 24 minus 16, which is minus 0.8 delta T. Delta T. So yes, this is also correct. So answer would be A and B only are incorrect. D is looking correct. E also would be correct. The geometrical arrangement of ligand in the complex is same as NiCO4, which is also correct. NiCO4 is also tetrahedral, just like this particular complex. With this, we move on to our next question. Next one is a homework question for you. I want you to answer it in the chat box. It's a very similar question which we have done. Homework question number 1 for the day. Tell me the answer at the bottom. Okay. Low spin octahedral complex means strong field ligand is coming. Right. Now moving on to the next one. It's a question from the valence bond theory where we have to tell the hybridization of the following complexes. First one is cobalt plus 3. Cobalt plus 3 means a D6 configuration. And the ligand is a strong field ligand. With a strong field ligand, we know forceful pairing will happen and the D6 will be able to fit into first 3 orbitals like this 1, 2, 3, 4, 5, 6 and it will go for a D2sp3 hybridization inner orbital complex. It's a correct one. So A is correct. With this, option C goes out. A is correct. Now let's check for the B. MnCl6. So manganese plus 3 means D4 configuration and weak field ligands are coming. Weak field ligand means it has to be D4 means there are no 2 rooms vacant. It has to go for outer orbital sp3d2 outer orbital complex. So it is also correct. sp3d2 outer orbital complex. B is correct. The first option also go out of picture. Now let's check for C. See carefully. They are saying outer orbital and then they are writing D2sp3. Obviously, it is not possible. How outer orbital can be D2sp3? D2sp3 has to be inner orbital. So it's a wrong statement. Either this is wrong or this is wrong. You can check it. So C is wrong. So this option also goes out of picture. So answer is A, B and D only. Okay, you can check for the D and E. A, B and D will be the answer. Next is total number of unpaired electrons present in the central atom. This particular one, this one. This is also a question which we have just solved a few minutes back. We'll quickly see it again. Nickel plus 0, because this is nickel 0. Nickel 0 is D10 configuration. D10 means 0 unpaired electron. D10 means 0 unpaired electron. Nickel plus 2 means D8. D8 with a weak field ligand, which will go for sp3, and 2 unpaired electron will remain. Platinum plus 2, D8. With platinum plus 2, every ligand is a strong ligand. So always it will be diamagnetic, 0 unpaired electron. Nickel plus 2, again D8, this time strong field ligand, just like a previous one. So here also will be diamagnetic. Platinum plus 2, again I told you, always will be diamagnetic, 0. So we have 0, 2, 0, 0, 0. So 2 is the answer. Okay. 2 unpaired electrons are there total in all these complexes together. Moving ahead, we have among copper ammonia 4 plus 2, nickel En 3 plus 2, these 4-5 complexes are given. Out of these 4 complexes, Mn water 6 plus 2 has the maximum number of unpaired electrons, which has to be true. Manganese plus 2 is a D5 configuration. D5 with a weak field ligand means 5.84 Bohr magneton, highest unpaired electron. Not more than 5 are anyways possible in any complex compound. 5 has to be maximum. I don't have to check others. 5 has to be maximum. So yes, it's a correct statement. Second says number of pairs among, this is one pair given, this is one pair given, this is another pair given. The number of pairs that contain only diamagnetic species are 2 pairs. Let us see. Both should be diamagnetic. First is para, just now we have discussed. Next is dia. So this is not a pair which we are looking at. This is para, this is dia. Again, this is not the one we are looking at. This is dia, this is dia. So only one pair is there. This is the pair which has diamagnetic species. So there are not 2 but only one pair. So first option is correct, second is incorrect. Right. Moving on to the next one. Again, same question. I want you to answer it in the chat box. Homework question number 2. Answer in the chat box. One of the most, favorite complexes of NTA or NEET is going to be these 3 complexes. Nickel complexes with the cyanide, carbonyl and chloride. The ones which are directly given in your NCERT as well. Okay. And the next one is X is the number of GIs exhibited by this compound. This compound is a MABCD type square planar compound. Square planar compound. And you know that here there are 3 different geometrical isomers are possible. One is where A can be trans to B, then C will be trans to D. A can be trans to C, B and D trans. A can be trans to D, then B and C will be trans. So X is 3. NCERT says out of the 3, 2 are cis and the third one is trans. So yes, 3 GIs are possible here. Why is the number of optically inactive isomers of this compound? This compound is written here M, AA twice, B2. There are 2 symmetrical bidentate ligand and 2 monodentate. Very important complex, one of the famous complex, one of the favorite complex of, examiners. In this, there are 2 GIs possible, you should remember. The 2 monodentate B can be trans to each other, which will look like this, or cis to each other. If I draw trans, then the bidentate ligand will attach like this, trans to each other. If I attach the 2 B's cis to each other, let's say this is cis, then the 2 rings will attach like this, cis to each other. Okay, we should remember that trans is optically inactive. Trans is the inactive one. Cis is the active one because cis has no plane of symmetry. So cis will have two options, dextrorotatory cis and levorotatory cis. So this particular complex has three stereoisomers. One trans, two cis. One trans, two cis. They are only asking about inactive one. So I am talking about the one trans here. The trans isomer of this. Okay. Z. Z is the number of GI exhibited by CO ammonia 3 and nitrito 3. This is a A3B3 type of complex, and all of us know this show two isomers. One will be facial and one will be meridional. If you are reading the NCERT well, you should know this complex by now. It has two GIs. Meridional is also called as trans. Facial is also called as cis. Okay, facial can also be called as cis. Meridional can be called as trans. So 2. 3 plus 1, 4 plus 2, 6. So they are saying total you have to tell. So total 6 are the x plus y plus z value. Right? Moving on to the next one. Question number 17, which says, statement 1, hybridization shape spin only magnetic moment of K3CO carbonato thrice is sp3d2. See beta, carbonato is an oxygen donor, and these are all weak field ligand. Oxygen donors are always weak field ligand, like water is weak field ligand. Okay, oxalato is one exception for cobalt plus 3, but in general OH minus is weak, water is weak, oxalato is also weak. It's a weak field ligand for us. So weak field with cobalt plus 3 have to go for outer orbital. That is correct, sp3d2. It is octahedral, yes, because here carbonato is acting like a bidentate ligand, so octahedral. And CO plus 3 means D6 configuration. 4 unpaired electron will make it 4.9 Bohr magneton. So it's all correct. It is all a correct statement. Then they say geometry, hybridization and spin only magnetic moment of these ions. Nickel cyanide 4 2 minus, just now we have seen was DsP2 and it was diamagnetic. So that's absolutely correct. DsP2 diamagnetic. MnBr4 already we have seen, sp3 it was, and it was paramagnetic with 5 unpaired electrons. So this is also correct. Cobalt plus 3 will be 4.9 with a weak field ligand and outer orbital complex. Absolutely correct. Both the statements are absolutely correct. Correct. So this is the one. We have two more questions here. Let's see the 18th one. 18th one says statement 1. The number of paramagnetic species among them is 3. Let us see. Cobalt plus 3 means D6 with weak field ligand. So yes, it is paramagnetic. You can see same question only keep repeating. Similar types of questions only keep repeating. Titanium plus 3 means D1. D1 has to be, paramagnetic. V2O5 means vanadium plus 5. V plus 5 is D0. So it has to be diamagnetic. Here is iron plus 3 means D5 with strong field ligand. D5 has to be paramagnetic because odd electrons can never be dia. So 3 is correct, absolutely correct. Statement 2 says these are some of the complexes given. Correct order in terms of unpaired electrons present in the complexes. Unpaired electrons. K for FeCN6 will be 0. 0 unpaired electron. It's a iron plus 2. D6. D6 with a strong field ligand. D6 strong field ligand. No unpaired electron. Next is a D5 strong field ligand. It will have one unpaired electron when you write the configuration. So it is looking correct till now. Iron plus 2, D6, but with a weak field ligand. D6 with a weak field ligand will have 4 unpaired electrons. And iron plus 3 with a weak field ligand, D5 means 5 unpaired electrons. So yes, it's a correct order of number of unpaired electrons 0, 1, 4 and 5. I hope all these questions are making sense and you're feeling more confident now. And this is going to be the last question. I want you to pause the video. Try this question first yourself. I'll give you a minute time and then I will discuss it. I want you to do it yourself. Tell me the answer in the chat box. I'll tell you how to do, but it's a homework question number 3 for you. And this is the last question of the video. I want you to first think about it and answer it. Then I will tell. I hope you have tried it. Now, let me show you the way to do. Consider a mixture X, a mixture of 0.4 mole of this complex. I am calling this complex with a little smaller name. Let's call it PBr. P is this cation. And 0.4 mole of this complex, let me call it QSO4. QSO4. Q is this cation. In water to make a 4-liter solution. So, first thing what we did is, we prepared a 4-liter solution. So, this total volume is 4 liter. We added 0.4 moles of PBr. So, concentration of PBr will be 0.1 molar. 0.4 moles in 4 liter. And concentration of Q sulfate will also be 0.1 molar because that is also 0.4 moles in 4 liter. Okay, molarity we have found. Next they say, when 2 liter of this mixture is allowed to react with excess of AgNO3, means we cut this solution into 2 halves. 2 liter we have taken separate, 2 liter we have taken separate. Obviously, molarity is a intensive property. Molarity will not get cut into half. So, this is still 0.1 molar PBr, still 0.1 molar QSO4. This is also still 0.1 molar PBr and 0.1 molar QSO4. They are saying first 2 liter mixture of X is allowed to react with AgNO3. So, we put AgNO3 into it, excess of AgNO3. AgNO3 will precipitate all the bromides here, giving you AgBr precipitate. How much AgBr will form? Each of this ion is giving 1 bromide outside the bracket. Okay, so the moles of complex will be equal to moles of AgBr. So, moles of AgBr will be same as the moles of PBr taken. How do you find the moles of PBr? Molarity into volume. Molarity is 0.1. Volume is 2 liter. Molarity into volume. 0.2 moles of AgBr will precipitate out. Okay. 0.1 mole of Y is formed. Y is AgBr only. This is why they are calling it. 0.1 mole of Y is formed is incorrect. 0.2 mole of Z is formed. 0.4 mole of Z. Now let's see Z. Here we have added BaCl2. Barium will precipitate all the sulfate out. So BaSO4 will form, which they are calling it as Z. Moles of barium sulfate will be equal to the moles of QSO4 because each QSO4 is giving 1 sulfate. So whatever sulfates will be there, that many moles of BaSO4 will be formed, which is again molarity into volume 0.1 into 2, 0.2 mole Z will form. So second option is correct. 0.2 mole of Z is formed, 0.4 is not formed. Why is BaSO4? No, Y is AgBr, whereas the Z is barium sulfate. So it's also a nice question. You can all look at it. Okay. I hope there is no doubt in today's class, whatever we have studied till now. So I will leave you with this. That is all for today's class. We have discussed 20 questions from the coordination compounds, which are most probable questions. Most of the concepts which are there in the chapter we have discussed here. Okay. So I hope you have enjoyed it, and thank you very much for listening to the class. All the very best for your RE-NEET exam. I'll see you in the next video. Thank you.